All right, so we are going to be starting chapter 17, section 4, talking all about generating electricity. So up until this point, we've talked about what electricity is. We've talked about how magnets are involved in generating electricity. So what this section talks about is in our country or in the world, how we essentially produce electricity to get to our homes. It's a big section. You could have an entire chapter devoted to it. You could have an entire class devoted to it. And we're just really touching on the basics, the big things. All right, so making and transporting electricity. So most electricity is made in a power plant. Most of us get our electricity from a power plant. There might be a few random people who don't, but for the most part, that is what most of us do. Most power plants will either burn coal, oil, or natural gas to heat water. That water, once it gets heated up, produces steam, which then turns a turbine. And as we've just recently learned about, in that generator, going to produce electricity when you turn the turbine. So real basic concept, heat something up. Heat up water, create steam, just like when you put water on a stove and you put a lid on top of it, you heat it up, that lid would kind of bounce around. Same thing's going to happen. If I burn something, I heat up water, it's going to create steam, turn a turbine, make electricity, and then send it off to our homes. So major ways that are done, coal, oil, and natural gas. Just to give you a kind of general idea of where we are at for a country, this is from 2017. It was the most recent one I could actually find, but 2017, how energy is generated in the United States. The first one, 32%, highest amount actually comes from natural gas. The United States has a decent amount of natural gas reserves. For us, 30% is then coal, and then 20%, shockingly, maybe that's a shock for you guys, is nuclear. The rest of it, kind of the rest of that little piece of the pie there, is what we consider renewable energy. Most of those are renewable energy sources we'll talk about a little bit later on. So for the most part, that's where we get it. So you could combine those two together and say 62% of electricity generated in our country comes from burning fossil fuels, essentially. Give you an idea here of how things have been changing a little bit over time. So this is from 2010 to 2020. You can see what's happening to coal. So coal, we've had a decline there. One of the issues with coal is it really is a big polluter. Creates lots of air pollution. There has been some technology that's come along to reduce that air pollution, some scrubbers that they put on stacks and things, but it still produces that. Natural gas is a little bit cleaner burning of a fossil fuel, and you can see how that's going up. These are two things that we have a lot of in our country. We have these resources. We don't need to get them from elsewhere, so that's an advantage. That's a good thing for us when you look at where we are getting those things from. Nuclear, as you can see, is kind of flatlined, hasn't really changed much. I do think I've read some things about maybe that might be on the uptick a little bit. And you can kind of see renewable for the most part on the bottom there is kind of staying the same, but it really only takes a matter of anything happening for any of these things to shoot up and go in an opposite direction. Maybe you get a new technology that makes something cheaper, so then that renewable might go up. So these things can obviously be changed by multiple factors. So electricity from fossil fuels, so as we just saw, it's the major way that we get electricity in our country. Fossil fuels are what we call non-renewable resources. Non-renewable resources are things that do not get replaced. So as we use them, it takes much longer for them to get replaced than it would in the amount of time that we are using that resource. So they're considered non-renewable. So what that means to us is they are going to run out. There is a point in time where you say, I only have this much, it's not going to come back. So fossil fuels are substances found in Earth's crust that were formed millions of years ago from the remains of dead organisms. Millions of years ago. So when you say you only have so much of something and it takes millions of years to get replenished, when you look at how life works on Earth here for human beings, it's not going to get replaced. It is not going to get replaced for us to use it. So if you have this resource, you have a couple of things you should be thinking about here. First of all, we're going to run out of it. So if you're going to run out of something, it's just like if you have something in your house. If you know you're going to run out of bread, maybe you should make some plans to figure out how to get more bread, or understand that when you don't have any bread in your house, you're not going to be able to do things like make toast and make sandwiches. So you can prepare for that ahead of time. So that's one thing. The other thing is looking at what they do to the environment. So if you know these things do things to the environment that aren't so great, then maybe we should think about not using them anymore. Now, this is a really complex subject. I'm not going to get into it today. I'm just going to mention it here. It's not as easy as just saying, I'm going to stop eating bread. It's a little more complex than that. You go on a low carb diet, that's easy to do. Fossil fuels, we rely on them heavily for multiple things. So it's really impossible to say next week we're stopping using fossil fuels. That is not realistic. But like I said, when you talk about being ready, being prepared, those things make a lot more sense. So our three main fossil fuels are coal, oil, and natural gas. Coal is a solid fossil fuel that is mined from the ground. North Dakota has huge coal deposits. In the southeastern part of the United States, there's large coal deposits. Oil is drilled from natural deposits, or it can also be filtered from the sand. We do get oil. Think about Alaska. You can think about Texas off the coast, the Gulf of Mexico down there in Texas. But most of our oil is imported, and it's actually imported from Canada, shockingly. I think a lot of times we think it's from the Middle East. It is obviously or shockingly from Canada. Natural gas pumped out of gas pockets from the ground. And like I said earlier, we actually have a lot of natural gas deposits here in the United States. So coal and natural gas and oil are usually all found kind of next to each other. They're often not in separate parts. So coal, as you can even see in the picture here, is dirty. It is. When you burn it, it's going to obviously produce air pollution. Natural gas, like I said, is much cleaner. You see on the bottom picture here, that's an example of one way we can get oil out of the ground, is an oil rig that's going to pump it out of the ground. If any of you have been to North Dakota, these things should look familiar to you. North Dakota has a lot of coal. They're also did have some oil that they discovered a few years ago. I think they've passed the peak production on that. And if you've driven out there, you might notice flames coming out by there, and that's because there's natural gas deposits there as well. And it's just not economically viable for them to capture that natural gas to send off to customers, so they just choose to burn it. So advantages of fossil fuels, like I've stated, U.S. has good supplies of it. So it's cheap for us when you look at coal and natural gas. We don't have to get these things from other countries. Oil, on the other hand, is a different story. But coal and natural gas, we can get those things. So that's an advantage. And another advantage of fossil fuels that I don't have written on here is that they produce certain products for us that are nice for our lives. Plastics, for example, are petroleum-based products. Those are nice. Plastics do things for us, and they have a lot of great functions for us. Disadvantages, as I've already discussed, they're non-renewable. They will run out. There is not a question of, no, they're not going to run out. You could sit and have an educated argument about each one of those things, about when they're going to run out, but factual information, they will run out. Like I said, just like if you know you're going to be running on a bread at your house, maybe you should get ready ahead of time. Reduced air quality for human health. So even taking anything else aside, this reduces human health. When you are breathing in these pollutants, it is reducing human health. It's why if you look at people who live in cities where you have increased amounts of air pollution from transportation or factories, there is a much greater risk of having respiratory disease if you live in cities, and a much greater risk of having lung cancer if you live in those locations. Now, another thing, we're going to get more into this later on, is climate change. So fossil fuels, when you burn them, release carbon dioxide and other greenhouse gases into the atmosphere. Those greenhouse gases trap heat. Now, it's a really complex argument. You notice I didn't use the word global warming. I don't like that anymore, and a lot of people are kind of getting away from that. It is much more complex than that. It is not just global warming. You have some places that can get warmer, some places that can get cooler, some places get wetter, some places get drier. So it's really complex. So that's why climate change really is a great term to use there. So electricity from nuclear energy. So as you saw in the thing earlier, we actually get in the United States about 20% of our power from nuclear energy. France, for example, actually gets most of its power from nuclear energy. Shockingly, almost all of it. Now, what they do to produce power from nuclear energy is you take the radioactive element uranium, and you set off a controlled nuclear chain reaction. And it's actually called fission. So they take, and it's almost like when you play pool and you break in the beginning of it, it's very similar to that similar process. You take uranium, you shoot things at it, it splits apart, but it's done so in a very controlled reaction. In that process, when these atoms split, they release a lot of energy, they release a lot of heat. So same thing again, we're using that heat to create steam to turn a turbine, is all it is. Now it has to be controlled. This is essentially how they make atomic bombs. It's just done in an uncontrolled manner. And as I just stated, it's important to keep the process cool. We have had nuclear accidents. United States had 3 Mile Island out east. Russia had Chernobyl. That's a very famous nuclear accident. And then Japan in the last, few years had Fukushima, which was a result of a hurricane. Now, all of these things essentially had accidents because of human error. And since then, everything that I've read, they've talked about how really there's no room for human error anymore, and that can't happen. You just can't get it hot and get it out of control. So advantages to this, there is no air pollution. When you guys look at these sort of funky towers that you see there, those are cooling towers. And all that is steam. There is zero air pollution coming out of there. That's it. Disadvantages, uranium stays radioactive for very long periods of time. Radioactive waste is not a great thing to have around because radioactive waste can cause cancer. It can cause severe illnesses. So there's the problem. What do you do with the nuclear waste? So currently in our country, I think the nuclear power plants, as you can see on the map there, all the red dots are where they're at. And yes, shockingly, even in Minnesota, we have 3 nuclear power plants. So what do we do with the nuclear waste? There was a project set up a few years ago that tried to figure out what to do with the nuclear waste. It's since been disbanded. France recycles all of their waste. It's economically viable for them. For us, it is not. So for the most part, I mean, it really is not a bad source of energy. If you make sure everything's contained, everything's controlled, it really isn't when you think about it. Electricity from renewables. So those are considered non-renewable resources. So these are renewable. So renewable resources, now these things are natural resources that can be replaced. So especially if we are respectful of them and we don't overuse them, nature through its natural processes will replace them and we will never run out of them. We are not going to run out of wind. We're not going to run out of trees. But like I said, if you replace them responsibly, obviously if we pulled a Lorax and cut down every single one of the trees, then we're not going to have any trees. Same thing with water. If we're responsible with water and manage it properly, then we're not going to run out of it. So as you can see in the picture here, renewable resources account for about 11% of consumption by energy source in the country. I would only imagine that number is going to be going up. In Minnesota, if you guys can look on the picture on the right here, so Minnesota, this should look a little bit different to you than the slide that I showed you earlier. You can see our coal is a little bit more, our natural gas is a little bit less, our nuclear is a little bit more. Remember, we have those 3 nuclear power plants here. But one thing that you will notice is that pie from renewable energy is a little bit bigger. And it's actually, if I could have found one from 2019, it would have been even bigger. It's interesting that Minnesota had a goal by 2025 to hit 25% renewable energy, and we've actually already reached that. So it's 2020, and we've already reached our goal that we set by 2025. And then Minnesota recently pledged, you can see this is a recent, well, it's not that recent, I guess a year. Minnesota pledges to be carbon free for energy by the year 2050, so in 25 years, which when you think about it, if we reach 25% by 2025, it's pretty realistic to say, okay, in 25 years, let's try to get that number up even more than that or all the way up. So another type of renewable energy here, or a type of renewable, is hydroelectric power, hydro meaning water. So hydroelectric power primarily uses falling water to produce electricity. So there's a couple of ways that can happen. The major way is through hydroelectric dams, like you see on the picture here. Another way is taking water and then pumping it to a specific location using nature when times are good for electricity, and then using the advantage of gravity to pull it downwards in times when you need the electricity. So advantages of hydroelectric power: there's no air pollution, zero air pollution. Water is renewable, so because of the water cycle, this should always be there. it is pretty readily available. Think about across the United States, most places you can find flowing water. Some disadvantages is when you look at this, I have a picture of Hoover Dam on the lower left there. Think about what happened to just even construct that dam, and you think about what it was like before it was put there. So it's clearly going to have a long-lasting impact on the environment. It can either flood areas or it can cause areas to have no water that had water previously. You can make certain locations vulnerable to drought because you're regulating how the water flows, so impacting the flow and quality of water. Another thing that I don't have on the slide here is its impact to the fish population. So there's a lot of fish populations that rely on spawning up rivers. Now even look at the cartoon picture here and think about, pretend you're a salmon and you are trying to get up that. How's that? Good luck surviving, you know, the trip through the turbine there. Fish ladders, on the other hand, and I don't have a picture on here, there are some things that they've put in place to try to help fish get past that. But then you still look at this and go and think, do you think it's actually going to make its way, you know, going all the way through? You know, probably not. Largest dam on Earth, I believe that's on the Yangtze River there on the right-hand side there. So yes, we have some advantages, but just like you're going to find out with any of the other energy resources we talk about, there's usually always disadvantages as well. Geothermal, so geo means heat, so this is heat from the earth. It uses Earth's internal heat in the form of water or steam. Now, in the United States, we don't have a lot of locations where this can be done on a big scale to actually have a power plant to produce electricity for an entire city, but some places on Earth do. You think about the country of Iceland, Iceland being right along the mid-oceanic ridge there, lots of volcanic activity in that area. So they get most of their power actually from this method is geothermal heat. So you got to think about when you go down under the earth, the temperature is going to pretty much relatively remain consistent. Even for us here in northern Minnesota, you dig a hole down, even if it's 40 below outside, you know, it does not get to be 40 below in the ground, 6 feet under the ground. Advantages of this, no air pollution. There's no pollution. It's renewable, so you're not going to run out of the heat inside of the earth. Now, the disadvantages is it can be expensive to install. Depending upon how the geothermal plant or how the geothermal is set up, really what happens is you will often dig down wells, so think of like a water well, and then you have a pump that's just circulating that water. So as that water goes down, it just gets brought to the temperature of the ground underneath and then brought back up. That's all. So availability of it isn't great on a power plant scale size. When you talk about homeowner size, there are some limitations to that. I'm going to show you a picture here. So homeowners use what would be called, this is one method of it, this is called an open source geothermal system, where you essentially just dig outside, kind of like a big giant trench outside. Then you take tubes that you would fill with water, bury it in the ground, cover it back up with dirt. That water year round is going to be at about like 67 degrees. That's ironic because it sounds just like the temperature you set your thermostat at. So when you think about that, wintertime, it's going to be 67 degrees. Great. It's going to warm your house. Summertime, it's going to have the exact opposite. So summertime, when it's 90 degrees outside, you're going to be using that to cool your house off. So this particular system is kind of an advantage. It's being used as a cooling and as a heating. So this is one way to do it. Another way to do it is drilling holes down into the ground, just like a water well. That has a tendency to be drastically more expensive. An advantage to that, though, is you don't need all the space. When you think about if you lived in town, let's say you live in town and you want to dig one of these, you know, if you don't have a yard to do it, it's not going to happen. So there is a limitation with that. Biomass, bio meaning life. So this is energy that comes from life. So energy from organic material from living organisms. There's a lot of different ways we can get that. Probably the most common way is obviously wood. So if you've ever had a campfire before, you've used biomass as an energy source. We can use corn to produce ethanol. We can use that as a fuel. There's waste from industries, particularly the pulp industry. And then there's also a new way that they're doing it is taking algae and then getting oil from algae that can actually be used as a fuel source. There's a lot of other cool things that are pictured on the slide down there. So there's sunflower oil, there's switchgrass. Now the benefit to these things is these things grow, and there's bamboo you can see on the picture there too. They grow quickly. really quick. So you can take them, harvest them. It's not even like a tree. A tree, a lot of times you're having to wait a longer period of time. So if you can have a crop that you can readily harvest, obviously that's going to be an advantage to you. For algae, if you have in a controlled environment here, algae obviously also reproduces very quickly. That would be beneficial. So advantage, clearly renewable if managed, and it can be readily available depending upon where you live and the type of biomass that you're going to be getting off that. Disadvantages is they do burn carbon dioxide. So you are taking a living organism, a plant usually, you're burning it, it's going to release carbon dioxide into the air. However, we consider that to be carbon neutral because that plant, to be alive, took in that carbon dioxide through the process of photosynthesis, and you're just putting it back into the air. So it's what we call carbon neutral. You're not adding additional carbon dioxide to the air like you would with fossil fuels. Wind power. Wind power uses wind to move turbines in a generator to produce electricity. I don't know if you guys have ever been up close with one of these before, but they are massive, really, really big. Most of the industrial ones that you see, like in the picture there, 7.3% of all electricity produced in the United States was wind power in 2019. Advantages, no air pollution, and it's renewable, obviously. Disadvantages, it is costly to install. It is very costly to install these. Like I said, these things are huge. So you can imagine if you're a power company, the amount of money it costs to put one of these up. There has been some harmful impacts to bird populations. So when you think about birds migrating and flying through, obviously they can hit the turbine blades, and that's not good. And also the wind doesn't always blow. You can't put these up anywhere. Up by us, the only ones that we have are the ones that are on Mintech property, kind of in Virginia. Eveleth over there, that was the only place that they found after they did wind studies as to where it would be economically viable to put them up. So the wind doesn't always blow. Also, when we talk about time of day, the wind actually most often blows at nighttime. And when you think about that, what are people doing at nighttime? They're sleeping. So we're not needing that electricity at nighttime. So you need some sort of a battery backup or storage capacity for that. It's a great use put in farmland because farmers can still grow crops underneath it. That's an advantage. You can see these other ones are off the coast, off the coast of the ocean. But then you start to think about, aesthetically, does that look the nicest thing? Imagine all these people that build homes on the ocean and then you say, hey, we're going to put all these wind turbines out there. I know there's been a few projects in the United States that have been squashed for that very reason. There's some really cool different blade designs. I just didn't want you to think it was this one blade design. I pulled these two off. Those are ones that are actually homeowners where you could buy them like at Ace Hardware and then you put them up on your house, which is pretty cool. Wind capacity by state. I just wanted to point this out. Clearly, the windiest we got there is Texas. But when you look at Minnesota, we're really honestly not that bad either statewide. Wind power in the United States 2018, as you can see here, yeah, it makes sense. Texas having the largest amount there. And Minnesota, I mean, we're definitely near the top there, right? Compared to the other states. Solar energy produced from the sun. So there's a couple of different ways that we can use solar energy. So we have active solar, which would be like a solar panel, which has essentially some sort of an element that's sandwiched in between material, as you can see on this picture here, that gets excited when the sun hits it. And when it gets excited, those electrons jump, and that's all we need for electricity, right? We got to get electrons to jump, and that is how solar panels work. Now, passive solar is a little bit different. I'm going to show you a picture in here what I mean of that, and that is essentially just using the sun to heat things up. Now, advantages of this, there's zero air pollution. So when you have a solar panel on your house, you're not producing any air pollution. It's renewable. Solar is really available in most locations. Even for us, you think northern Minnesota can't make it work. No, easily can work. We definitely have enough sun outside for that. So it's readily available anywhere. After you have that initial install costs, there's very low maintenance, you're not paying for anything after you install that solar panel. Now, a disadvantage would be is if you have your solar panel hooked up to your house and you have no power company, you need battery backup. Now, a lot of them now are set up where if you want to have it fed back into the grid and not have battery backup, then you can do that. An advantage to that would be is most power companies will actually pay you. So if you're producing electricity on a day and you are making way more than you're using, it gets fed back into the grid and they will actually pay you. pay you to produce that extra electricity. Expensive to install? Yep, can be very expensive when you think about most homeowners and saying, hey, this is the amount of electricity that we are getting, then yeah, very expensive. Here is a passive solar design house. So taking a look at taking certain things into account, having your house be south facing with a lot of windows so that in the wintertime you're getting a lot of sun, planting hardwood trees outside so that in the summertime they can block that sun, having eaves on your house long enough to block the sun as it comes in the summertime. Thermal mass flooring, having ceramic tile on the floor that can heat up when you need it to and release that energy at nighttime. So here's just a couple of pictures showing you of houses that have passive solar design. I've actually heard that the passive solar design can actually almost make it so you have zero heating or cooling cost if done properly for a house, which is pretty cool. And just showing you another picture here of the places. It kind of makes sense. Look at where solar power is the strongest on us for the United States. So solar is coming a long way. So this is called solar parabolic troughs. So they have a fluid on the inside of it. All of that energy is directed at the fluid. It heats the fluid up just like everything else, turns a turbine, all of those things. Solar is now, we're coming into the place too where we can make it so it's really thin and then have that be so that we can have different applications of it, even putting it, on, this is an example of a road construction of it. I mean, can you imagine if our roads were solar and we just use that to produce energy and get it to all of our houses? Like, how awesome would that honestly be? Lots of applications for solar. However, you got to watch solar. I have to say this much about it. When solar panels are manufactured in the United States, they're done so in a very environmentally friendly way. If you purchase a solar panel, let's say from China, and you just get it, that's not the case. So you have to ask yourself when you're doing these things, if you're doing it for the environmental reason, you should really research the companies that you're buying the solar panel from to make sure that you're not essentially contributing to some bad environmental policies if you're doing that. So lots of good things for energy, but hopefully you guys are just kind of getting overall there is advantages and there is disadvantages to every one of these things.